Today we'll discuss about ions. Now we know that atom cannot exist in the free form. There are some exceptions regarding this statement. These are inert gases. Now inert gases, there are helium, neon, argon, krypton, xenon and radon. These are all neon gases in our periodic table. These all gases are exceptionally stable. Why this is so? Because all of these gases except helium have 8 electrons in their valence shell. Now why this is so? There was seen that there are some elements which have 8 electrons in their outermost shell are exceptionally stable rather than other elements. So the theory was given by Lewis and Kossel that the other atoms other than inert gases try to attain this configuration. Means inert gases are ideal for them. So each and every atom try to attain 8 electrons in their outermost shell. Exception are light elements like lithium, hydrogen, helium. They cannot attain 8 electrons, but they can attain the configuration like helium, because helium have 2 electrons in its valence shell. So it is also a stable gas and regarded as inert gas. So to get stability, atom either form ions or molecules. Now first, what are the ions? An ion is a positively or negatively charged atom or group of atom. Positive or negatively charged atom or group of atom known as ion. Now ion may be of two types. Number one, if it is positively charged, then known as cation, and if it is negatively charged, is known as anion. Now conditions in which cations and anions are formed. So first of all we see cation. If you look at the periodic table, there are some elements which are in extreme left try to form cation to get stability. For example, if we talk about sodium, atomic number of sodium is 11. So electronic configuration of sodium will be 2, 8, 1. Now in this case, there is 1 electron in outermost shell. Now this electron plays a significant role in chemical reactivity of sodium. Now to attain a noble gas configuration or to attain a ideal gas configuration, it wants to complete its octet. So there are two paths. Either it gains 7 electron or it loses 1 electron. In first condition, the configuration will be 2, 8, 8, and second condition configuration will be 2, 8. But in first condition, -7 charge on sodium, and in second case there will be +1 charge on sodium atom. Now which is beneficial? Obviously second one, because it requires less energy, and -7 it requires a lot of energy. It is impossible. So sodium loses 1 electron and forms Na+. The energy required to remove this electron is termed as IE. Now we can define what is IE in a formal way. Full form is ionization energy. What is ionization energy? The amount of energy required to remove 1 electron from valence shell of an isolated gaseous atom. Now dear student, here seeing there is a term isolated. What do you mean by isolated? So we explain it. Suppose you want to remove electron from sodium atom. We can form the atomic structure of sodium. This is nucleus. Around the nucleus there are fixed energy shell in which electrons are revolving. Now you know that nucleus have proton and neutron, and in these fixed energy shells there are electrons revolving. Now in case of sodium there are 2 electrons in K shell, 8 electrons in L shell, and 1 electron in M shell. Now to remove this electron, the energy required is known as ionization energy. Now here we added one term, isolated. Now suppose I say you to remove the electron from the compound NaCl, and you remove electron from this atom sodium from the compound NaCl, then is there required energy will be same as that of the removing of electron from sodium atom? No, because this is not isolated. There is some effect of chlorine atom over sodium atom, so amount of energy will vary. That's why we have added one term, isolated gaseous atom. This is about ionization energy. Now there are another example to form cation like magnesium. The electronic configuration of magnesium is 2, 8, 2. So to attain a noble gas configuration, obviously it wants to leave 2 electrons. So magnesium finally forms Mg2 plus 2 electrons. Here magnesium is losing 2 electrons. So the charge on magnesium is develops 2. Why there is development of charge on a particular ion? We know that atoms are neutral in nature. They have equal number of proton and neutron. They have equal number of proton and electron. Now if you remove electron, there is the increment of positive charge. That's why how much electrons you are removing, there should be put up an positive charge. If you are removing 1 electron, so you should put a 1 positive charge on that atom. If you are removing 2 electrons, then there should be increment of 1 positive charge. Okay, now another example, you are taking aluminium. The electronic configuration of aluminium is 2, 8, 3. Now again, to gain a stable gas configuration, it will loses 3 electrons, and there will be charge of plus 3. So these are the cations which are formed by losing of electrons. And there are some similarities between the element which generally lose electrons. That's why they are fall in the same category, and this category is known as metal. Like sodium, potassium, magnesium, calcium, lithium, copper, zinc, aluminium, etc. They fall in generally alkaline metal, alkaline earth metal, and D block element, and some of the P block element. Now as you are seeing, by losing electron, they form a cation. That's why this property is known as electropositive character. So the elements which are showing this property are known as electropositive in nature. So we can say metals are electropositive in nature because they loses electron very easily to form cation. Okay. Now next one, is anion. Now, if you look at the extreme right of the periodic table, rather than inert gases, there are oxygen, nitrogen, fluorine, chlorine, bromine, etc., which have tendency to gain electrons to complete their octet. For example, if you talk about oxygen, atomic number of oxygen is 8 and electronic configuration is 2, 6. So again there are two paths to complete its octet. Either it gains 2 electrons and it loses 6 electrons. In first case the configuration will be 2, 8. In second case configuration will be 2. In first case there will be development of charge -2, and in second case there will be development of charge +6. So which is beneficial we can easily observe. So we can say the first step will be beneficial. So oxygen forms compound by gaining of electron. So we can say oxygen gain 2 electron and forms O2-. Now after gaining of electrons there is some evolution of energy known as electron affinity. Now what is electron affinity? We can define it in a formal way. Electron affinity. Now what is electron affinity? The amount of energy evolved during addition of single electron in the isolated single electron in the valence shell of an isolated gaseous atom is known as electron affinity. Now there are another example of anions like nitrogen. You know, atomic number of nitrogen is 7. So electronic configuration will be 2, 5. Now obviously nitrogen gains 3 electrons to complete its octet. Halogens are also falls in the category of anion. For example, Cl-, for example Cl, which form Cl- by gaining of single electron and forms configuration 2, 8, 8. All the halogens form monovalent compound: fluorine, chlorine, bromine and iodine. All the 4 halogens forms fluoride, bromide and iodide, because their valence shell have 2 and 7 configuration and it's have 2, 8. This is the case of fluorine. For case of chlorine, bromine, iodine, there will be 2, 7, 7. So 2, 8, 7, and there will be 2, 8, 8. This will be for chlorine. Now as you move further, there will be increment of electrons. Now these all elements, nitrogen, oxygen, halogens, fall in the same category. Now this category is known as non-metal. Means you can say non-metals have tendency to form an ion. So the elements which show this tendency to form an ion are said to be electronegative in nature, because they attain a negative charge on an element after getting an electron. That's why they are known as electronegative element. So we can say fluorine, chlorine, bromine, iodine, oxygen, nitrogen are electronegative in nature. Now, so far we have studied about formation of cation and anion. Now, are they stable or not? We have formed the Na+, which have 8 electrons in valence shell, and we have formed chloride ion, which have 8 electrons in their valence shell. Now, are they stable or not? Will they react or not? Yes, of course, they will react. Why this is so? Because they are not stable. Because there is a development of a charge on the sodium or chloride ion respectively. So, to lower the energy, they attract to each other. there is a formation of sodium charge and chloride ion. Both of them attract to each other and try to form a molecule. And trying to do so in this, they form a crystal structure for NaCl. Now, there are another category of ions like monoatomic ions, and the second one polyatomic ion. Now, what is monoatomic ion? Its name indicates the ions which are formed by a single atom is known as monoatomic ion. For example, Na plus, Mg2 plus, Ca2 plus, Li plus, Fe3 plus, they are monoatomic ions. Cl minus, O2 minus, N3 minus, these are all monoatomic ions. Now if we talk about polyatomic ion, its name indicates the ions which are formed by more than one type of atom are known as polyatomic ion. Example are NH4 plus known as ammonium ion, SO4 2 minus known as sulfate ion, CO3 2 minus known as carbonate ion, etc. Now our next topic is ionic compound. Those compounds which are made up of ions, that is cations and anions, and are held together by strong electrostatic forces of attraction are called ionic compounds. The forces which hold the ion together in an ionic compound are known as ionic bonds or electrovalent bonds. For example, calcium nitrate, NaCl, MgCl2, etc. Now how they form? We can take a simple example of NaCl. Here we have formed the cation Na plus and one anion Cl minus. Okay. Now how they form, you know that the oxygen wants to remove single electron to form sodium plus, and chlorine atom wants to gain one electron to form a stable configuration of Cl minus. Now the electron removed by sodium ion goes to chlorine. You know that sodium wants to remove one electron, and this removed electron goes to chlorine atom to form chloride ion. So they both, sodium and chloride ion, compensate to each other, and there is a formation of Na plus and Cl minus. Now we know that we consider the atom as a spherical shape, like that. Suppose this is sodium ion. Now we can put the positive charge on its sphere. Please don't count these positive signs. I am just showing that there is a equal distribution of charge on the surface of sodium atom. Now there is another ion, that is chloride ion, which is also, we can say, spherical in shape, but somewhat bigger than sodium ion, because this is an ion. Now again there will be equal distribution of charge of negative nature. Now you can easily observe that positive charge will attract to negative charge because these are basic forces. So there will be an attraction between sodium ion and chloride ion. So by the attraction of these, there will be development of a bond known as electrovalent bond, and to do so they form a molecule NaCl. So they comes too close to each other like that, and there will be formation of a compound known as NaCl. But remember always, this process is not stopped at only two ions. As we know, there is a charge which is equally distributed on the surface, so there will be equally attraction of the chloride ion towards sodium ion and sodium ion towards chloride ion. So there will be a lot of ions surrounding a particular ion, and the number of ion which surrounds the oppositely charged ion is known as coordination number. Coordination number of sodium was found to 6 and coordination number of chlorine was also found to 6. And formally, this is said to that the NaCl compound or NaCl crystal is formed by coordination number 6:6. Like that, you can form many compounds by compensating these valency. Now we can take another example. Take a metal, magnesium. We know that electronic configuration is 2 8 2. So to attain a noble gas configuration, it will form Mg+2 by losing 2 electrons. Now if we see toward chlorine, configuration is 2 7. So obviously it wants 1 electron to complete its octet. Now there will be attraction between magnesium ion and chloride ion. Now we know that there is +2 charge overall on the magnesium and -1 charge on chloride ion. So we know that a compound or molecule should be neutral in charge. So there will be 2 chloride ion to compensate the +2 charge. So simply we can say there will be addition of Mg+2 and 2 chloride ion and they form MgCl2. Like that you can form many compounds by using any concept.